I will start. Welcome everyone to our open house. We are here to sell you a home, not on Earth, but in space. I am Emily Lopez.
I'm Allison Trent.
I'm Kirti Bhattarai.
I'm Tom Ling.
And I'm Annika Sparrow.
And we are Space Place Incorporated. My lovely realtor friends here will elaborate.
Our goal is to find a way to make human life possible on other planets, and we want to develop a living settlement that's safe, efficient, and that we can essentially use to live on any other planet, and it could be adjusted to suit the needs of the planet. And this would bring in a new age of technology and space exploration.
As an example, we chose to investigate how we would colonize Ganymede, Jupiter's largest moon. It is rich in water and iron and passes through Jupiter's immense magnetic field, providing a potential energy resource.
So you all are probably wondering why we should live in space. Many people are skeptical of moving into space, but space colonization can solve various issues in the foreseeable future, such as overpopulation, as you can see in the graph, pretty understandable, and global warming. Also, our country is curious to explore outer space and demonstrate our leadership doing so. While researching, we found inspiration from sci-fi movies to biology. We used a diagram of a bacteriophage as the base for our rocket. So, as you can see, the head, the very top, is where we would store the materials for the exterior of the house. The neck, the middle part, is where the people and the supplies would be stored, and the legs, kind of all around the structure, would be where it would secure to the surface of the moon. We also used information from the Biosphere 2 in Arizona, which, yes, Emily is pointing to, for our research as conditions were similar to what we would be dealing with. These airbags just below would assist us in landing. They were actually used to land the probes on Mars, and the solar sails to the right of the screen would help accelerate the spaceship as we were landing.
So for our design phase, we actually started off with the icosahedron, which was this very interesting looking shape here, and we realized that it didn't really work because it wouldn't be able to settle into the surface of the planet as well. So then we moved to a more of a structure like a honeycomb, and the reason we did that is because the honeycomb is flat, it can connect to other areas, and the weight settles in the bottom. Now, you might be wondering, what exactly are we using for the materials of this? And I want to take a moment to ask, to just watch a video.
Look around you. Look around you. Just look around you. Have you worked out what we're looking for? There. Now take a closer look. Correct. The answer is fungi. This lesson, fungi, follows last week's lesson, poison, and will complete chapter 394 of your textbook. Please ensure that you have your copybook at hand, as you will be asked to take down notes from the screen at various points throughout the program.
So just a quick second to the adults who might not know what the heck is going on. We really liked the series that was like basically a spoof of a science show, and so I decided to do a little tribute to that. Anyways, for the materials, we like to use carbon fiber and titanium alloys because they're the strongest and lightest materials that we have on Earth right now. We're also going to be using a regenerating nickel-based metal to reduce maintenance and to prevent as many accidents. And as I said before, fungi, it can actually be used for the internal structuring. As you can see over there, that is mycelium, which is a product harvested from fungi that can be then repurposed into many strong materials like shown in the slideshow before. And we will also be using a solar sail to help us travel a little bit faster throughout the universe.
So how exactly are we going to get our home to Ganymede? Well, there are 3 basic stages. The first being over here, space travel. So as we can see, this is the solar sail, which Allison described earlier, and that is connected through a metal ring to the base of the actual spacecraft. And here we can see fuel tanks on either side of the spacecraft, which will then detach after leaving the atmosphere of Earth. The next stage is detachment. Detachment occurs once we enter the actual atmosphere of Ganymede. And as we can see, the different hexagonal prisms segments separate or detach from the actual base and decelerate towards the surface of the Earth through the use of aeroshells and parachutes. And these spheres that you see here are actually airbags that will inflate to provide cushion for when they land on the actual surface. The last phase is landing. And the base of the spaceship, which is down here, will land in this manner, and these legs will serve as stabilizers. And the connector ring that served to connect the solar sail to the base will also serve as a stabilizing mechanism. And by this point, each of the airbags under the hexagonal prisms or around it will then deflate and allow the hexagonal homes to attach to one another through self-assembly.
So with this model, you can see each wall, each rectangular face has 4 sensors in each corner, and each sensor is paired with another sensor giving off the same signal. So you could have 1A and 2A, 1B and 2B. And upon impact on the moon in this case, the sensors will activate, and each sensor will send out the signal, and when it finds the matching sensor, it'll activate the treads in the bottom of the module, which will help it to, using like locations, it will match up to each one, and then a tunnel, sort like a hallway, will be pushed out from the inside of the compartments, and it'll connect them, and they'll be airtight so you can go from module to module.
Okay, so to sustain our inhabitants on Ganymede, we project that we'll be able to mine materials from Jupiter's other moons, and our spacecraft will be coated in a self-healing metal to prevent further damage. And using Jupiter's magnetic field, we can string a carbon nanotube around the moon, and as it passes through the magnetic field, a current will be induced which will provide electricity for our base. To produce oxygen, we can split water molecules, because there's a lot of water present on Ganymede. And finally, for the food, we can use plants such as tomatoes and potatoes that can be sustained for a long time.
So have we convinced you to buy a house on space yet? Thank you.